Okay, I hope we have enough space on this disk. But the average rate of change of y with respect to x is the average rate, which is change in y divided by change in x. And we can write that as delta y over delta x. This little triangle is a Greek capital delta, which if it's turned on the side and rounded off a little, it kind of becomes a big capital D. Okay. So question, what's the average rate of change of this function that we just graphed, y equals 1 over x squared, from x equals 1/2 to x equals 1? Now remember, the graph has points here, here, and here, 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 and here. We're going from the x equals 1/2 point, which is this, to the x equals 1 point, which is this. Okay? So, we'll come back to the picture, but the question then is, how do we calculate the change in y and the change in x? Well, if you got the graph in front of you, you can see what the change in x is and the change in y, but I'll point that out in a minute. Okay, average rate of change of this function from this point to this point. Well, it's going to be the change in y divided by the change in x. How much does x change? That one's easy. If x goes from 1/2 to 1, the change is 1/2. From 1/2 to 1 is a distance of 1/2. Okay? Actually displacement, we want to use the right word. Change in y is a little bit trickier because usually the change in x is a positive change. So that's pretty easy. You don't have to think that hard about whether it's a positive or negative change. Y, in this case, changes from what? Well, y is this function. So if x is 1/2, y is f of 1/2, which is 4. We calculated that recently. And if x is 1, y is f of 1, which is 1. So y changes from 4 to 1. What's the change? Well, most people are going to say change is 3. Well, that's the magnitude of the change. That's the absolute value of the change. Saw some absolute values in homework last night. But the change is -3 because from 4 to 1, you're going down, right? And you subtract. The change from one thing to another is you subtract where you start from where you end. So it's where you end minus where you start. That's one thing you want to kind of keep in mind. Okay, so now on this graph, well, but the rest is calculation. Your rate of change then is delta y over delta x. Delta y is a change in y, that's -3. Delta x is a change in x, that's 1/2. And that's usually dividing gives you the -6. Now again, just a reminder, when you do fractions, make sure you understand how to do them. You absolutely need to be able to do that in this course. Here, on the graph, we can depict these changes. From x equals 1/2 to 1 is a change of 1/2, right? Well, this point is directly above 1/2, and to make it a little clearer than I did, if I keep projecting down, this point is supposed to be directly above 1. So you got right angles and everything here, so that this distance equals this distance, that's going to be 1/2. Of course, it's calculated by subtracting where you start from where you end. Where you start, subtracting from where you end, there's how you do the numbers. And the delta y's we saw is 1 minus 4 or -3, because of course at this point y is 4, at this point y is 3, is 1. And you get 1 minus 4 is -3. The slope then of this line segment is rise over run, which is delta y over delta x. Kind of a bad x there, wasn't it? Okay? Delta y over delta x. And that corresponds to the average rate of change. So the slope is identified with the average rate of change in that interval.